in today's video at Medical Sciences, where we want to discuss about tissue processing in histology. In the previous video, we have looked at the workflow of the tissue in the histology lab. We have looked at tissue reception and grossing. And this one now leads us into what we call tissue processing for soft tissues. Then we told you for hard tissues, before tissue processing, we do what we call decalcification, which we shall see it as a video in its own. So as we begin, we remind you to subscribe if you haven't, and keep liking the video and share to others. And under tissue processing, we want to discuss about the principle of tissue processing. We shall see three major steps in tissue processing, that is the dehydration, clearing, and impregnation. Then finally, we shall look at the factors that affect tissue processing. So the principle under tissue processing, which is a step after grossing for soft tissues, immediately we do tissue processing, whereby the principle here, we are removing the water. So the principle states that during tissue processing, we see removal of water, So we are removing water from the tissue, or fixative, either water or fixative which have been used from the tissue, then we replace it. Then it is being replaced by a support media. Here we replace it with a support media, and the support media is normally used in this majorly is the paraffin wax, and sometimes we can use celloidine or we can use gelatin. But the most commonly used among the support media here, we use the paraffin wax. Paraffin wax is routinely used as a support media. And this support media is the one that provides rigidity and firmness to ease tissue cutting or microtomy. So the aim of replacing water with a support media, which is firm, this support media should be firm enough, to enable tissue sectioning, but at the same time, as we are making this tissue to become firm, it should be soft to be enabled the microtomy knife to cut it easily. So much as we are removing water or fixative, replacing it with a support media, or a solid media, which is firm enough to facilitate microtomy. At the same time, this tissue should remain soft for microtomy knife to cut sections easily without distortion or damage of the tissue. So we are replacing it with this support media, which is firm enough to enable tissue sectioning without distortion, without damage to the tissue, without making damage to the tissue, and at the same time leaving it soft. It must be left soft to enable microtomy, knife, to cut sections easily. So this is the principle behind tissue processing. Very simple. Replacing water with a support media firm enough to enable cutting of the section without distortion or damage, while maintaining even the tissue soft enough for the microtomy knife to cut sections easily. So this is the principle majorly, replacing water with a support media, and the media we use commonly is paraffin wax for routine use, and this one, so much as we want to make it enough, it should remain soft. It should not crumble or become brittle, so that when during cutting, the microtome knife can easily make sections without any damage of the tissue. So this is the principle. And after knowing the principle under tissue processing, we go to the steps involved. And among the steps involved, one is dehydration, whereby dehydration is removal of water. Here under dehydration is removal of water. Removal of water from tissues. Whereby we want to remove, dehydrate means removing water from this tissue. And after removing the water, how do we remove it? We use dehydrating agents. And among the dehydrating agents used during tissue processing, much as here I have skipped, some books normally include fixation here as number one. So sometimes we can see books including fixation, and this fixation is included so that in case the tissue was not well fixed before, it can be fixed very well at this level. So sometimes they can give you 4 steps, or sometimes we can begin from dehydration. But sometimes fixation can be part of tissue processing. Then fixation, whereby we are making sure the tissue remains in its lifelike state without autolysis and putrefaction by the bacterial agents. But on dehydration, whereby we are removing water in the tissue, replacing it with the paraffin wax. Here, how do we use, which agents we use? We saw majorly the best dehydrating agent used here is ethanol. Ethanol is the one which is most commonly used. And this ethanol, which is used in this step, we use it in increasing changes. We use increasing changes whereby we begin for many tissues, we normally begin with 70%. Then we go to 85%. Then we can go to 95%. Then finally we go to 3 changes of 100. We take it to 100%, 100%, and 100% ethanol. So this is 3 changes. We use 3 changes of absolute ethanol. And we have said ethanol is the dehydrating agent of choice for dehydrating these tissues. But other dehydrating agents which can be used, apart from ethanol, we can use acetone. Acetone can be used. Butanol can be used. Isopropyl ethanol can be used. And sometimes methanol, but methanol is not good. So the best one is ethanol, which is used as a dehydrating agent. But for delicate tissues, if the tissues are delicate, here we can note for delicate tissues, we can begin, instead of beginning with the 70%, we can begin with 50% or 30%. So for delicate tissues, it is advisable either to begin with 30% or 50% as we ascend. Can go from 50 to 70% to 80% and so forth for delicate tissues. So this is the process of dehydration. And to enable the tissue to remain soft, or we normally use what we call softening agents, such as 4% phenol, or we can normally mix alcohol together with glycerol, and these ones prevent hardening. prevent tissue hardening. So that is the use of 4% phenol or glycerol during dehydration, adding it as a mixture to ensure the tissue remains soft without hardening during dehydration. And after we have removed all the water, after removing the water, we have to replace it with an agent which is miscible with both the paraffin wax and the dehydrating agent. And that one leads us to what we call clearing. And this clearing, sometimes you can call it de-alcoholization. De-alcoholization. Whereby clearing is that we are removing the alcohol or the dehydrating agent, replacing it with a soluble media or a media which is miscible for both the alcohol and the paraffin wax. So that's what we are talking about under clearing agent, whereby it is clearing here we are removing, it is removal of dehydrating agent. You remove dehydrating agent, then we replace it, we replace it with the clearing agent which is miscible. This agent should be miscible for both the paraffin wax for impregnation and the dehydrating agent. Should be miscible or soluble for both. So after adding this clearing agent, it removes the alcohol. That's why we are calling it de-alcoholization. It removes the dehydrating agent, and we are replacing it with this clearing agent, which is an intermediary. It is the one that is going to communicate between the dehydrating agent and the impregnating agent, which is paraffin wax, which is most commonly used. And among the clearing agents commonly used, one of them is the most commonly used is xylene. Xylene is a dehydrating agent suitable for routine histological sections, and it is most commonly used. Why? It is a fast in action, but though it causes brittleness of the sample. And another one we can use is taurine. Taurine can also be used. Then we can also use chloroform. Sometimes we can use benzene, though it is very volatile and flammable. And sometimes we can also use tetrachloride, carbon tetrachloride. So these are some of the clearing agents used, but the most commonly used being xylene, which is suitable. Then for chloroform is suitable for CNS tissues, central nervous system tissues. Chloroform is suitable, very fast, and it does not cause brittleness. Then taurine for it, benzene for it is very slow acting, but still does not cause brittleness of the sample, of the section. But we said xylene, very fast in acting, but causes brittleness in case it takes longer during this clearing agent. And the major aim of clearing the sample is to make it transparent. One of the importance or significance of clearing, one is to remove the dehydrating agent. Is to remove the dehydrating agent. That is part one, because the dehydrating agent is not miscible with paraffin wax. And after removing the dehydrating agent, at the same time, we are making it transparent, to make the tissue transparent. Make tissue transparent or translucent. Why are we making it transparent? Is to enable microscopy, easy microscopy without any hindrance. So those are the two significances of clearing, that is removing the dehydrating agent. That's why we are calling it dealkalization. And another importance is why we make it clearing is we are making the tissue very clear, that is transparent, so that during microscopy it is easier to visualize different parts of the cell. So those are the major two significances of clearing using these clearing agents, which these clearing agents are acting as a bridge between the dehydrating agent and the impregnating agent, which is alcohol paraffin wax. After looking at the clearing, lastly we can look at impregnation as the last step under tissue clearing, under tissue processing, whereby impregnation or infiltration, here we are replacing, after removing the dehydrating agent, after removing here, we are going to remove the clearing agent. You remove the clearing agent. After removing the clearing agent, we replace the clearing agent with molten paraffin wax. We use molten paraffin wax, which is the most commonly used. But apart from paraffin wax, we can also use gelatin. Gelatin is normally for frozen sections. If you have frozen sections, then gelatin is the best impregnating media. Then for celloidine, it is good for soft tissues. So if they bring among the multiple choice questions that which of the following is the best impregnating media for frozen sections, that is gelatin. And if they ask you which of the following is the best impregnating media for soft tissues, that is celloid. And these impregnating agents such as paraffin wax, they are always in a molten state, and this one is done at the temperature between 56 to 60 degrees centigrade. That is the temperature where we apply this impregnation. And sometimes for quicker results, we have to apply vacuum. Vacuum is so good. Vacuum pressure, or the vacuum is what you call negative pressure. This one causes faster impregnation, whereby the spaces where the clearing agent was, we remove it by absorption, then we replace it with molten paraffin wax. And to use the work, it should be at this temperature and under vacuum, or what you call negative pressure, to avoid longer impregnation, which can result into brittleness and cracking of the tissue section during microtomy. So this is what we can talk under impregnation. And this tissue processing can either be done manually, or we can do what we can use automatic processor. And whenever we are taking these tissues and these tissues, we told you that they are always in tissue cassettes. When I have these tissues in the tissue cassette in a container with holes, so we make sure we maintain constant agitation. When it is in the container, we have to maintain constant agitation in each. When we go to dehydration, we have to make sure there is agitation. The clearing, there is agitation, and even in impregnation, there is agitation, so that we can cause filtration, quicker filtration of these agents. And under tissue processor, we normally use even activated charcoal. And the role of activated charcoal is to absorb the fumes which are produced by either the fixative or any other agents we are using. So there is always activated charcoal to absorb the fumes which are produced by this tissue processor. So that is what we can discuss under impregnation, or what we call infiltration. Removing the clearing agent, replacing it with this molten paraffin wax, which is firm enough to enable microtomy. And it is done at temperature between 56 to 60 degrees, which is for 4 degrees or 56 to 60 degrees centigrade. And we have said the vacuum also determines the vacuum, then the size of the section also determines the rate of impregnation and even the density. So this one will result into the factors that affect, whereby one of the factors that affect tissue processing is temperature. We have temperature, we shall have vacuum, or we shall see pressure. Pressure being the point. Pressure, then another one is agitation. Then another factor we can talk about under here is size and density and size of the tissue can also determine, and also the type of the type of the impregnating media. Then even the time can also be a factor. And the temperature, we have said the temperature, the best one during infiltration, for example, it is between 56 degrees to 60 degrees. That is during infiltration. So below it will result into raw infiltration, and above it can cause brittleness. Then pressure, we said for faster, it should be negative pressure or under vacuum. So when you provide vacuum or negative pressure, the faster the rate of impregnation. Then agitation, constant agitation also increases tissue processing time or decreases the time. This one decreases the time. So the more you agitate, the more the entry of the impregnating media. Then the density and the size, the smaller the size of the section, the higher the rate of tissue processing. The processing will be faster. Then the type of impregnating media also determines, and even the time it spends in. And normally the time we normally use, the recommended time is always between 30 to 60 minutes. But many times in every station we take 1 hour, which is 60 minutes. 1 hour. 1 hour is always used in each station. So when you are in 70% alcohol during dehydration, 1 hour in each. So you find the whole tissue processing can take like 14 hours. That is a full day, more than a full day, daytime. So this is what we can discuss under tissue processing, whereby we have seen the principle where we are removing water, replacing it with a support media firm enough to enable cutting sections, but at the same time leaving the tissue soft to enable the knife to cut without damaging. Then we have seen fixation in case they were not well fixed, whereby we can continue fixing them in 10% formalin. As we know that 10% formalin is the most commonly used. This one can also be for 1 hour. Then we dehydrate, whereby the most dehydrating agent we have seen is ethanol. That is the suitable one. And in each change, we take 1 hour in each change, 30 to 1 hour. Then we have seen we can always mix in 4% phenol or glycerol to prevent hardening of the tissue. Then we have seen clearing what we call dealcoholization, which is whereby we are pressing a dehydrating agent with a miscible, a soluble agent with paraffin wax, and the majorly used is xylene, and for CNS it is chloroform. And we have seen the significance is to remove the dehydrating agent and making the tissue transparent. Then lastly, we have seen impregnation, where we are using candle wax, paraffin wax being the most commonly used, and sometimes for frozen section gelatin, this one for soft. And temperatures we have seen and the vacuum. Then we have ended up with the factors that affect tissue processing. Thank you so much for learning until the end. As we always privileged, we are always grateful to make medical sciences your learning center. May God bless you.